Thank you so much for coming to our session, and welcome to Bridging Research Computing to tackle really hard, complex global challenges. I really appreciate you being here today. I'm Deborah Goldfarb, and I run products and strategy at AWS for what we call advanced computing and simulation. And of course, HPC and large-scale machine learning is part of our portfolio of products. I'm joined today by three amazing people, luminaries in their individual fields. And we're going to talk about collaborations between research institutions and universities and industry. Each one of the people on this stage represent part of a broad collaboration, set of collaborations that we are leading within our organization. And these collaborations are extremely important to us on so many levels. One, it really pushes the envelope of possibility thinking. We're early in the days of HPC moving to the cloud. There's so much promise, and these collaborations really represent our ability to sort of lean into things of first of a kind in the industry. So these are very important, and we're going to talk about all sorts of things today, the highs, the lows, the possibilities. And so why don't we start with each of our panelists introducing themselves, starting with you, Francesca?
Sure. My name is Francesca Dominici. I'm professor of biostatistics, data science, and population health at the Harvard THN School of Public Health. And right now I'm the director also of the Harvard Data Science Initiative. And we will talk more about what this is. Thank you for having me.
Satoshi?
Okay, so I'm Satoshi Matsuoka. I'm the director of Weekend's Center for Computational Science. Weekend is the premier national lab in Japan doing all kinds of science. And our center is one of the 13 centers, but also do double duty as the National Center for High Performance Computing. And we developed and host this machine currently called Fugaku, which is one of the fastest in the world. And we do all kinds of cool science.
Sure do.
Yeah, my name is Ceci Su. I'm Associate Director, Solutions Architecture in the Emory University Research Solutions. We are basically the part of the central IT in the university. I've been helping researchers working as the technology partner for over 20 years at Emory. In the last few years, I've been focusing on helping them to navigate the cloud. I'm the lead of our customer service team. We support researchers and onboard them to use our AWS at Emory platform, which is Emory's own customized platform on AWS.
Thank you. So why don't we start with you, Francesca, if we can. Tell us a little more about the Harvard Data Science Initiative, and then if you can sort of move that into the kind of collaboration around impact computing you're having with AWS.
Yeah, sure. So the Data Science Initiative at Harvard is been designed to literally be Harvard-wide, and I'm not surprised I'm here preaching to the choir, but you will all understand that the data science is now a discipline that it's pretty much present in any conceivable scientific and inquiry, but also in general in the humanities as well, and in the divinity school at Harvard, Harvard's 12th school. So we wanted to create a university-wide research hub to advance data science, both in terms of data algorithm, data analysis pipeline, data engineering, and application to solve really important problems. Now, I've been really fortunate to lead this initiative for many years, and then we realized very quickly that there is really, it's essential to advance data science to solve problems that we try to tackle this challenge together with industry. We really, in the academic world, try to advance data science and solve problems without industry. I think at this point, it's very naive. And so we had this unique opportunity, and I'm so grateful to Deb and Nelson Gonzalez to really start and having, I would call it really a collaboration, but it's truly an intellectual partnership, because and so we had really this really important, fully alignment of our intellectual agenda and goal. And ultimately, the goal is to tackle some of the greatest big challenges, from climate food security, social determinant of health. But then we have to do it together in terms that I think in the academic world, we might have world-class computer scientists that are developing the latest and fanciest machine learning algorithm, but then, as we're gonna talk about, they have absolutely no access or no expertise of how to train this massive amount of algorithm on the cloud. Or we come up with the best possible statistical methodology to assess causality, but then we don't have access to the high-performance computing or the secure cloud that we have. So this has been a really fascinating experience, a wonderful learning experience for me and my colleagues at Harvard, to really sit down with the Amazon Web Services leadership and see, okay, if we want to solve and combine large amount of multimodal heterogeneous data to basically provide very timely information to policy, how do we do that together? And so we're embarking in this adventure, and really see how many times we'll be here and telling you all of the things that we're learning from each other.
Exactly, and it is an adventure, truly. Satoshi, talk to us about virtual Fugaku and what we're doing together.
Okay, firstly, Fugaku as a physical machine, that's a machine we had developed and built in collaboration with Fujitsu as a national flagship machine we worked on for like 10 years. It's a very large machine. It has 160,000 nodes or about 8 million CPU cores. So it's a ginormous machine. Just, it's like a cloud. Our data center is like one of the hyperscaler data centers. So the machine is huge. That said, we're sort of, and the machine runs very well, thankfully, in producing lots of scientific results, basic science, industrial results, so things to really advance and save the society and all that. Now, in some sense, we're a victim of our own success, because despite this humongous machine, 160,000 nodes, which is one of the top machines in the world, we're constantly full. It's like we're like 95% capacity, constantly full. Now, when we think about everything that we have developed, it's not just a machine. We developed the software stack, we developed the applications. Of course, we do science. We'll have lots of scientific teams, in both internally and outside of my center. And so the project of developing a very large machine is not just on the hardware itself, but it's really the whole ecosystem from the science to both industrial, but also basic science to industrial, all the way down to the systems. And for this really successful outcomes to proliferate, just building this 160,000 node machine, despite its size, is far from sufficient. So we want this results or assets to proliferate to society at a much larger scale. And it just turns out that Amazon had developed their own processor, Graviton, which is binary compatible with what we have developed, A64FX, and have very similar performance characteristics. So so it was a great opportunity to work with Amazon to extend our assets over to the cloud. So basically, inject this supercomputing environment, so to speak, directly into the cloud, so to proliferate much further than a single machine. Also, will allow Amazon to benefit, because these high-end applications, for example, they scale to thousands, even tens of thousands of nodes, and those are not very everyday type of applications, but they do great science. So for Amazon to be hosting this will also advance Amazon's own abilities. So I think it's a real mutual benefit that we do this. So really to virtualize our assets to virtualize and realize Fugaku, the same environment, same applications, onto AWS.
It's an amazing project. Think of the ultimate digital twin of the Fugaku environment hosted in AWS. It's pretty extraordinary. We'll come back to some of the big stories there as well too, but Cersei, talk to us what it means at Emory to be a cloud-first research environment.
Yeah, so Emory has a cloud-first policy. What it means is that as a central IT, what it means as a central IT, when we considering new IT infrastructure, we have a very, very strong preference to put that in the cloud. And our cloud-first policy really started like 6 years ago by our former CIO, Rich Mandola, and also his deputy, who is our current CIO, John Ellis, with the support of the university senior leadership. And they did it not just because they think that the cloud is cool and they like it. They really see the opportunities that in the cloud being a game changer for our researchers. Opportunity that our researchers, they can get the latest CPU and GPU when they need it. They don't have to wait until the next cycle of equipment refresh. They also see the opportunities that our researchers, they can get it when they need it. You know, they don't have to go through the lengthy procurement process or rack and stack, you know, those servers in our data center, right? They also saw that, you know, being the central IT, you know, we can focus on providing great customer services to our researchers and being, you know, work on our DevOps practices and don't have to, you know, sidetrack by running those hardware on premises. And also opportunity that using the cloud, we can transform some of our critical IT resources from their legacy format, you know, to the modern architecture. For example, we are moving our clinical data warehouse right now from our on-premises, you know, legacy format to AWS data lake. So there's a lot of great things happening, you know, in Emory with the cloud-first policy.
Thank you. I'm going to stay on sort of come back this way. You know, there's often challenges for researchers around, they go to the cloud and there's this fear of cost overruns and how do you manage your grants and how do they get allocated against your budgets. Talk to me about how did you navigate the landscape of the transition from on-prem infrastructure to the cloud?
Particularly about cost,
Around
right?
costs, yeah.
Yeah, so we have learned about the fear about cost from our researchers, you know, in terms of run rates, EC2 workload, about the fluctuation of cost, right, in the past few years. So we really developed our own training curriculum that focusing on, you know, for our researchers who have no really IT formal training, they just want to do their data science work, right? So in our introductory training that, you know, we have it, you know, every month, you know, we're focusing on best practices, security, and also cost, right? Make sure that you use AWS budget, make sure that you shut down those EC2 when, you know, terminate or stop when it's idle. But even with those trainings and repeated messages, sometimes our researchers still running into, you know, struggling with the cost. So we recently, that's one of the reasons that we have built a new high-performance computing cluster on AWS using the parallel cluster that Deborah team have, you know, the architecture that they designed. And one thing with this parallel cluster, Slurm cluster on the cloud, one of the advantages that between the Slurm and AWS integration, when there's a job running, the compute nodes will launch automatically. And then when the job finishes, the compute node will terminate automatically if there's not another job running. So it really gives an automated kind of way that to prevent the EC2 run rate, you know, issue. Another piece that we have been working on, and we really have a great FinOps, you know, finance operation person at Emory, who oversees all of our AWS spend and also actively manage our compute saving plans. With the compute saving plans, we are regularly offering 30% off EC2 compute usage cost, you know, to our researchers. And that's a big saving, right? So if you have not looked at compute saving plans, I definitely recommend you to check it out. So,
yeah. Thank you for bringing that up. Yeah. Francesca, you wanted to
Yeah, I wanted just to follow up and provide,
Yeah.
I mean, I completely agree, but also it's interesting because I can provide the perspective of the faculty PI and the educator and the professor in everything you're saying. And I think it's interesting because, I mean, still now, I can speak for sure at Harvard that, you have no idea how many times I have conversation, even though I'm not the expert on research computing, I'm just a PI, I just do my science, and then, there is the faculty professor that said, well, I have $10,000 and I'm gonna spend the $10,000 and I'm gonna buy a computer, and high performance, and I know for you, see, they're cringing, they're like, oh my God, that's why I wanted to say, but this is still happening now, and they're saying, well, because, I can put my students there, and then so what I'm trying to say, there are two things. One, I do think that also is important from the cost-wise to also really compare and tell the faculty is like, yes, you're spending $10,000 here, but that's what would be the advantages, in addition of all of the other advantages that we are talking. The other thing is in terms of, and mentioning about the fact that doesn't matter how big is your computer, how big is the cloud, it's gonna fill it soon, very, very fast. And so as an educator, as a professor, actually my lab, what we are trying to do, and I would love to start, having actually a campaign, is the fact that regardless of whether or not how you're paying for these computing cycles, you need to start thinking about in an economic way of how you use these computing cycles. And one way to do it is also to improve your programming practices. And so because of what's happening right now is that even if the PI pays, right, or the university pays, the student or the postdoctoral fellow, they throw at this machine as much as computing cycle that they want, and they're not spending the time to do efficient programming, because sometimes with efficient programming, you actually, so I think I call it like, coming from the School of Public Health, actually good health behavior, right? Yeah. In the same way you're eating parsimoniously, you should also, programming in a way that minimizes the carbon footprint and the computing cycle, regardless of how much it costs.
Exactly. Use Fortran.
Use Fortran, right.
Satoshi, do you want to add anything to that? I mean, at Reconnect,
Yeah,
how do you do that?
Well, it's not just in Japan, but these big machines, like we have, what DOE has, like, or some of the NSF centers in the US, or some European centers, et cetera. These big public machines are usually allocated just as you would allocate funding. So there's, when you apply for funding, you submit to like NSF or somewhere. And there's a committee, and people decide how much money you get. Okay. Very same thing with computing. So, so after you get your funding, it's usually the model is after you get your funding, then you submit another proposal to the computing center or the national board that actually allocates these, and then the board kind of decides how much compute time you get, and so for most compute savvy people who've been using these very large machines for a long time, they're pretty much used to this procedure that they do this, like double submission. Right? They submit once, well, actually for money they submit twice. The second time for cycles, and that's what they get. Now, what's been happening, however, and then the alternative choice was to just buy their small machine. What's been happening with the cloud? Cloud is just like with the more supercomputing power now going into the cloud, like for example with Graviton 4 and all the GPUs and so forth. This model, you have this you have the secondary entity, which is a very different type of charge model, which people are not used to. Right? It's not there. There's no, at least for the time being, there's no judgment process or the decision process where you get your allocated cycles as if you're allocating, as monetary resource, you allocate a compute cycle resource. There's no process for doing that. On the other hand, you can very easily overspend, because if you're buying a physical machine, you go through some process and you get this fixed machine. But you may have a grad student. This actually happens for allocated cycles too, but they go wild and they spend all their allocation for just a month, and for the rest of the year they can't do anything. And this happens all the time. So, and of course, then you ask for additional. But then, since this is direct monetary funding that you get, you pay for your cloud resources. It doesn't quite work in a way that the traditional allocation policies have been doing. So there has to be some standardized process, I think, where the cloud resources can be allocated in a very sensible way, with some adjustment process so people don't go rampant and wild. However, be flexible so it's an alternative source of cycles. It's not an easy problem to solve, but it is a different type of funding model, especially with the US and Europe. In Japan, it's been more prevalent because some supercomputers have been used under a charge model, but a lot of the researchers in the US and Europe are sort of not used to that. So that's, yeah.
Yeah, I do. I agree with you. I think that I think as a community, we have to actually think about some systematic way to do it, as well as make sure that when grants are written, they have cloud-based cycle time that's actually built into the grant, as opposed to trying to force fit a research computing budget to this, and the grant doesn't really allocate. It gets complex. And the thing we don't want it to have happen is it to limit the science and the research activities. Satoshi, I'm going to kind of dig a little here on something that we talked about previously with your big idea around, people have used the word democratization of supercomputing. That concept's been around for a long time. It's almost used to the point where it doesn't mean much anymore, but suddenly it does again, because perhaps the cloud is the unifying or equalizing kind of environment. So I'm curious, talk to the audience a little bit about what this means for virtual Fugaku, how you can imagine the impact of the cloud around being this kind of ubiquitous resource. And
Well, Deborah, as you mentioned, this democratization idea, for example, we have had since 2000, late 2000s. In fact, the machine Fugaku is Mount Fuji. And the reason the machine was named Fugaku, Mount Fuji, was because not only Mount Fuji, you probably have seen pictures, it's the tallest mountain in Japan, but also it has a very wide base. So that so the base, so being tall, being high, having high performance, but also have a very broad base or ubiquity, was the simultaneous satisfaction of both properties was the ideal. And so the machine, even Fugaku itself, already to some extent idealizes this concept of democratization. That's why I adopted ARM, and that's why, of course, we work Graviton and X4FX. They fit together very nicely. Well, that said, we still see lots of issues with supercomputing in general, because being unlike more, I would say, traditional cloud. Well, it's funny to say that the traditional cloud computing environment.
What is an untraditional cloud?
I don't know. I'm saying, like Fortran's been around for like 50 years, but for example, cloud's only been around for like 15, so it's hard to say traditional. But but compared to those types of more democratized environments, a lot of supercomputing environments are still very customized, and partly because of performance requirements, but also because of the there were less interactions with the rest of the IT. But now with if the AI and also not just AI, but all the applications, all the societal applications requiring this high performance, because quickly there's a requirement. But a lot of the supercomputers have still retained this arcane model of having very customized software stack. Connectivity with cloud being less than desirable, not supporting REST API, which I think is pretty crazy. Fugaku does support a whole bunch of REST APIs who can connect to Amazon. So we can connect to Amazon directly, for example. So all of this, but we came to a realization that the reason why this is so is that typically people like to, people with big machines have this big machine mentality. They want to create their own empire. Right? So we said, okay, that's not good. We have to have more standardized software environment. We need to have the applications installed, just like in the cloud environments. We need, like the marketplace, we need all the applications ready to run. We need not just the software being installed, we need standardized way of help desk support, everything. such that the people using machine A can jump right off of machine B, machine C, et cetera, without any sort of extra learning required for the particular environment. And that's still not there. And that's one reason why we want the environment to proliferate.
Exactly.
And that's the basis, some of the basis for the idea.
Love it.
Yeah.
Francesca, I want to talk about impact to the edge, right? So HDSI has a big agenda. The Impact Compute collaboration has a big agenda. How do we think about, when we think about collaborations between industry and academia, how do we ensure that we get to the last mile, right? Whether it's policy or insight or devices or something, we're learning amazing thing, take crop yields in Madagascar, right? We're doing some work on food security together. How do we make sure that we move from sort of this academic mindset and have it move through an ecosystem to its intended? And if you could maybe talk a little bit about some of the work you've done historically and some of the hopes for this collaboration.
Yeah, no, that's a great question. So I think also just to segue to where we had this conversation about the research computing, as I was listening more and more, I think that this is really the time to have this totally cultural shift where there is not the science and there is the research computing. The research computing becomes the science. And which is the similar thing of saying there is not the academia and the industry. This has to be really totally cultural shift. Why? Because if we wanted to solve the most intractable problem in society, let's take the issue of climate and food security in the global south. From a scientific, we are dealing with data that are bigger at the fastest scale, crazy multimodal, from satellite images to try to convert with natural language processes text. So data are becoming larger, multimodal, messier from heterogeneous data sources. The algorithms are becoming also more complex, and they need to be trained on this gigantic data set. So in one hand, we are developing all of these phenomenal cloud and other tools and other algorithms, but we need to literally work together. What I mean working together is in the same way when I'm trying to tackle the problem of climate change and food security in Madagascar. I have someone who is expert in ecology. I have someone who is expert in remote sensing data. I have someone who built data pipeline. I need to have someone who is expert in research computing. I have to have someone who is expert in data engineering. There is not an hierarchy of skills. These are all the series of skills that needs to be seated at the table together, right? And so what I'm really looking forward for our collaboration is just actually doing that. It's creating, I think for the first time in history, an environment and an ecosystem between Harvard and Amazon Web Services where we are all embarking with the same goal, which is really creating everything, the entire data pipeline from the data lakehouse, from the high performance computing, that then, because if we can figure it out ahead where to overcome food security in Madagascar, we can scale it to another country and another country and another country, right? And again, when we're talking about research computing, it's very important that, one of my own objectives as a scientist and someone that lead data science at Harvard is that it's not that research computing is this thing, it's right there when I need to call someone to get help. It's someone who is part of the team that we are developing problem. Because you can develop the largest computer in the world, but as you also realize, there has to be some customized, right, to be able to access. And that requires really intellectual expertise in understanding the science that we are going to try. So I'm extremely excited the fact that data science, which I'm passionate, I do think is one of the revolution that can really overcome tremendous amount of challenges in the world. But I do think that the path forward is really to think about the entire data science pipeline to be considered in an ecosystem where we are all sitting at the table, learning from each other, and being able to enable the scientists to train this machine learning model with the right data, with the right computing, with the right speed, with the right criteria of sustainability, with the right level of open source and transparency to allow reproducibility, and then to enable collaboration. Because going back to the exciting thing about the cloud and many of the things that the Amazon Web Services provides is that if you're working in that environment, and then you have the data lake house here, and then you have the access to the secure cloud here, and then you have the software here, then let's say that you have solved it in a particular ecosystem for a particular scientific problem. It's really easy to bring another team and another scientific problem and build on that environment that you have created. Right now, it's crazy for me to think about, even if I think about Harvard Medical Campus and Harvard School of Public Health, we are probably talking about thousands of PIs and laboratory that they doing their own things within their own four walls, and we don't know what's happening to the person next door. So I'm extremely excited. I think that's where the future is. And I think the most important thing is a change of culture and a mutual learning and the humility to learn from each other, because I think that's where the future is.
I appreciate your thoughts on that. I noticed it resonated with you. Any thoughts on,
Yeah, I hear Francesca, you mentioned, being a partnership, right? Research, IT, and scientists. So I totally agree with you. I mean, at Emory, we have research IT divisions created, more than 10 years ago. And we were there to enable researchers being the trusted partner using information technologies. I mean, this is working with them side by side, designing algorithm, looking at, solutions that can be, help them to advance their research, right? So that partnership is not just a phone call. It's like conversations, understand your need, and continue work sessions to get to, the research outcome. So I totally agree with that, yeah.
Satoshi, thoughts?
Yeah, well, a panel may not be very enjoyable if everybody agrees. But
Disagree, please.
No, but I have to agree. I'm sorry. But let me put it in a different way. Although, of course, I agree, but let me put it in a different way. Because I've been in this business for many years. And certainly there's been a there's been a significant cultural shift, as you say. Because this big computing mentality has been like, you have this big machine and you run this one big application once and you get this fantastic, like now exaflop results, and that's your mantle, and that really doesn't achieve anything scientific. Right? In fact, computing has seeped into every corner of scientific endeavors, not just businesses, but science. Science cannot be done now without computing. And also computing is bringing science much, from the basic science to the actual applications. It's really bridging the gap.
Yep.
So this innovation cycle is getting much faster. Now, so then what kind of computing infrastructure do you need? Well, certainly you need a platform, a computing platform. And in some cases, of course, you still need big cycles, right, to do these very detailed simulations, like first principle material simulations, or doing big AI training and all that. They would still require big machines. But it's all part of this large large workflow now. You just don't run a single application just once. You don't do that anymore. To do real science, to do real sense, to affect the society, you construct a workflow on this platform of services that's either generic or particular to a domain. And then it's these workflows, maybe these components may be simulation-driven, maybe AI-driven, maybe like data-driven. It could be various sorts they interact in the workflow. And then, we run this workflow in various ways to come to a result. So for example, one of the pharmaceutical workflow building, we'll have services both on Fugaku and AWS, because a lot of pharma companies have data already in the secure AWS data lake. And they would do, for example, as part of the workflow, they will do federated learning, using their own data to do distributed training of their part of the network. But then that's all gathered together onto Fugaku to construct this larger trained network, and then this trained network will be used in the workflow. Again, the services both in Fugaku for certain simulations, in the AWS for certain simulation services and for AI services and so forth. We have more than like 100 components which will constitute this workflow. So that's science today. It's a collection of various components in the workflow, and you really need to build this platform to allow the scientists to easily build their customized workflows pertaining to the domain. And for that, services like AWS is essential because there are already pre-existing services, or even if the new services are created, they can be, just like you said, they can proliferate globally. So AWS cloud will become a very important element in this whole platform for science, computing platform for science infrastructure.
I agree with that.
Yeah.
I'm going to sort of change this up a little bit, and I love asking people, if you knew then what you know now, what would you do differently in all the things that you're working on, specifically with AWS? In other words, these things are hard, transitions to the cloud, doing science in the cloud, all these things, it takes leadership, it takes focus and alignment across organizations. So if we could talk a little bit about some of the opportunities and challenges you've seen and some of the sort of the learnings that you now know that had you known them when you started on this journey, you might have, maybe a little wiser, maybe you'd have made different decisions. Cersei, you want to start?
Yeah, I have to say that, I see what Emory has done, in the last few years. Our organization has gone through like amazing transformation. We start from, knowing nothing about cloud. We have, trainings, within our central IT for trainings, and also being a really cloud practitioner ourselves, develop deep cloud AWS expertise. So I think that along this journey, I feel like we are doing it, the way that it should be. I think that, early on we have made some really important investment, and that really pay off, now. Like we have developed our own AWS at Emory platform that is secure, and it can also support HIPAA workload, which is very important to university like us. We are health sciences research, have an academic research center with us. So we make the investment, and at the time, AWS, didn't have the confinement pack, they didn't have the AWS config, so we have to build our own security control IT components, and also make it, integrate with our identity management system, finance system, our ticketing systems, and make it, really for our researchers that is as frictionless as possible when they use it. And I feel that investment definitely pay off. We also make sure that, the VPC connect to our on-prems with really good direct connect. It has been 10 gig, and now we're actually making it 400 gig through internet too, at where I'm talking right now. And we have a dedicated team that we provide, training and onboardings, and solution consultation and all that, and it's really free of charge to our researchers. So all that, it pay off because right now, we have like 270 user accounts, over like 1,000 users using AWS at Emory. And if you ask me doing anything differently, I think that we actually should be doing exactly what we've been doing.
It's amazing. I mean, just one point I would love you to make is talk about leadership, where leadership played a role in kind of really setting the vision and sort of making sure that, I mean, academic organizations are like organisms, right?
Yes.
You know, they are dynamic creatures, and so how did, you know, you're laughing.
Yes, yes.
Harvard is like a hydra. I mean, it's just like, so what, I mean, obviously it's leadership matters, but particularly I think at Emory it really.
Yeah. At Emory, like I mentioned earlier, Rich Mandola, and also his deputy, Mark Overcash, you know, who is over the research IT. I think I mentioned earlier that, you know, they created the research IT within the central IT 10 years ago. So we have a very long history of trusted partnership with researchers. So it's not like that they haven't helped us for 10 years, and now we say move everything to the cloud, right? We already have that trusted relationship that we provide solution recommendation. They're like, yep, that makes sense. So, and then they also, you know, with the leadership, you know, the investment and commitment to build the platform, and also, you know, that a team to support our researchers, all those are very important. Now, Emory is just like any academic institution. You know, there's a lot of freedom, right? Our faculty has freedom. They, you know, free to, you know, purchase on-premise, you know, even now on-premise hardware and put it into the lab or put it into the data center. So there's absolutely no mandate at all to use the cloud. And I think it's really unrealistic to say that you have to use the cloud without giving them the choices. However, our leadership believes that, you know, if we build the platform right and it can address their need and we provide great customer service, they will come. So, and our figures really speak for themselves. You know, we have a lot of user accounts and we have a lot of success stories. And I feel like that, you know, given that we have about 3,600 or so faculty at Emory, we have 270 user accounts. You know, that's really a really high utilization of the cloud. So,
Excellent. Satoshi, thoughts?
Well, if I were to do things differently, the short answer would be we would have worked with cloud vendors like AWS in a much closer fashion from day one. Because, you know, for example, when you look at the Graviton 4, which will probably be a stellar chip.
It's going to be a
Right.
stellar chip.
Yeah, but when you look, but you know, I'm not putting it down or anything, but you know, it'll be a great chip. But when you look at ACE-Core-FX, our chip, they look very similar, right? Of course, you know, Graviton 4 uses more, you know, a little more advanced process. Oops.
Oh, that's okay.
A little bit more advanced process and so forth. But then you ask the question, okay, so if Graviton 4, if ACE-Core-FX seems like the genesis of Graviton 4, why isn't it in Amazon in the first place, right? Right now we're in the process of designing our next machine, and instead of a more classical model of working just with Japanese vendors, we're now undertaking the effort to work with the other more international vendors like Intel, NVIDIA, AMD, HP, and so forth. And also we're starting to this whole collaboration with Virtual Fugaku I'm hoping it'll enlarge to the extent that and we'll work with Amazon in designing our next infrastructure. Because there are a lot of things we can do together. Right?
I agree.
The processor, for example, is one thing, right? But you know, others. There are lots of technologies that Amazon's developing, we're developing, that can be we can do together. Or there are a lot of areas where things can be complementary. Well, there are established Amazon services. We don't need to we don't need to take the effort to develop it. We just say, well, for this we'll use AWS. So we're like so we do cutting edge as a government lab. We work with the vendors to develop this next generation cutting edge technologies. Like looking at our next machine will likely be 2027, 28 timeframe. And so we're developing towards that. But by working closely with the forerunners, just like AWS, I think we can have a much more fruitful relationship in that that both parties will benefit, and we'll have much better technological advance. Will enable much better technological advances by this collaboration. So again, I would say that working from day one, which we are starting to do for the next mission, with AWS is something I would have done and try to do right now.
I love that. That's exciting. Francesca?
Well, many things I would do differently.
We've learned a lot together along the
We
way.
learn a lot together. And also, it really depends from all of the different roles I have. So I think in one role as an educator and as a professor, I do think that I really want to start bringing the concept of using the cloud and research computing to the student, from the undergrad to the master to the graduate student, when they're thinking about developing the next AI algorithm, how they're going to run it, how they're going to train it, on what, right? And these are all concepts they are not thinking about. And so that's one thing. As a faculty and as a scientist, I mean, just, my entire research has been pretty much analyzing the entire US healthcare system to understand the impact of environmental contaminant on health. And it's crazy for me to think that, for a very long time, I'm analyzing million of health records for the entire claims data without working with AWS and industry and really getting the right data engineering and high-performance computing. On the other hand, it's also true that there have been, both cultural and financial barrier, right, in doing that. And as director of the data science initiative, I think, sooner we could get this started, better it is. That really, I am very proud of where we are and the mutual learning that we are doing. But I'm also realizing and being very humble about it, that there are enormous, not scientific challenges, but really institutional challenges in taking two institutions, Harvard and Amazon Web Services, and trying to be fully aligned. I mean, I'm also proud to say that the data science initiative and our research computing environment at Harvard, and my colleague Scott Yokel and his team, we have been working very closely together. And again, it's a learning for them as well. So a lot of things I would have done differently, but mostly doing it sooner and faster. But I'm really excited about our future, but also I'm very aware about the fact that this is really an adventure.
It is. I mean, and this goes to all of you. I mean, it's, as you point out, all of us represent very large organizations.
Yep.
We work at different paces. We have different metrics that guide us, right? Finding, for any of you who are in the academic computing world, universities or public sector organizations, and you're looking to be in collaborations, building those tenets of how you operate together.
Right.
How do you drive alignment in terms of your goals, in terms of the cadence of interaction, some of the most basic things. How do you get through the complexity of the legal challenges of working together, and which is always, it goes from like big lofty ideas to these most basic things of how you operationalize. And you're right. I mean, it's you can see the outcomes that could be extraordinary, but it's getting through these sort of micro and macro things to get to the other side can be hard.
But that's where leadership comes in, right?
Definitely.
The true leader doesn't want to solve simple problems. The leader wants to solve hard problems.
This is so true. It's all those BHAGs, big, hairy, audacious goals. I want to give a moment to see if anyone in the audience would like to ask a question, something they're curious about or want to follow up, because we have about 10 minutes left in the discussion. We have someone who has a roving mic, if anybody. It's very hard to see.
Yeah, we don't see you, so just stand up.
Was there a question there?
There's a gentleman back
Excellent.
there.
Hi there.
Yeah.
There is no, I'll repeat it once he says it, but he hasn't.
I run a small team of software developers who help research at business school, and just curious to know where you see a research software engineer, how they fit into the process. Mostly asking Francesca or Tracy. I recognize it's not available at all universities, but I'm curious to see with a lot of young PhDs and young faculty coming in with programming skills, and like, where do you see that role fit into the process of research?
Yeah.
Let me repeat the question in case others didn't hear it. So the gentleman was asking, where software engineering, perhaps a student with a PhD, where they fit into the process in an academic environment in both these collaborations and in some of the domains. Is that characterized? Okay, yeah.
So I'm going to tell you my dream and my vision, which will never happen, but it's good to have a dream, right? So my dream is actually as part of the data science initiative to really build a cohort, what I call it, professional data scientists in the institution. So my huge frustration I have right now, which I'm sure it's common in all of the other institutions, is that we have this academic path, right? So there is the PhD student, and then the postdoctoral fellow, and then the faculty member. And then there are all this enormous talent of data scientists, from including software engineering, data engineering, all expert in research computing. They are in this different world, right? And connecting these two will be phenomenal. I know we are connected, but not really. And so what I mean by professional data scientists is let's lift up this community, providing more like an academic scientific title, and finding a way that they can be more naturally be embedded into faculty laboratory. Let me give you an example, right? So there is a research computing team that Serge is leading at Emory, and I'm sure she has a lot of very, very, very talented people, right? I am a faculty member at Emory. I don't see who is in her team. And some of them, with the understanding, might want to spend some time and working with the lab member, right? Why these are two different teams? It could be a very symbiosis way, right? And so in the same way that at Amazon in the industry, we have this tremendous talent of data scientists with different expertise. That's what I would like to be able to do Harvard. And they will also provide a path for job and academic, and for a career path for our own PhD. I mean, not only Harvard PhD, but any other PhD. Because right now what we do is we train and then they either go to industry or they have a faculty position. There is another area which I would say are what I call professional data scientists, not that because are better, but they're just data scientists that instead of doing only service work, they're more embedded into the science. And I think we still haven't figured it out, but I don't see why we cannot make it happen.
Yeah, so more like a rotation program, right? The expertise, with the software development, work with the researchers in the lab for a few months, finish a project, rotate to a different lab. They embed with you all and understand your needs.
And you could have some people in your lab that have no interest and want to stay in your, that's perfect. You want to have some that maybe they want to spend most of the time and they want to come back. I mean, there could be different models, but I don't see why. And that would be phenomenal for you as well because they're going to bring the science back, right?
Satoshi, you have something you wanted to add to that? Yeah.
Okay, so, well, firstly, so we're in a very privileged position because we're the top national lab and we're the National Center for HPC. So, all the people we have in research, even in operations, most people have PhDs. So we're very highly skilled, a pool of highly skilled people. That said, if you take a look, and if you're in an institution like RECAN, where everybody has a PhD, and so as a researcher, you are actually, it's a pretty tough environment because you're expected to produce academic results, which are like papers and awards and all that. And after a while, if you do this for 10, 20 years, you may succeed, you may move on. If you're a successful researcher, you may carry on, still doing great research. And typically, these people also they're great programmers too, by the way, especially those people we hire, obviously. They're great domain scientists or computer scientists too, but even domain scientists, they're super programmers. They can program, most difficult, unstructured, like precondition, with very, very difficult type of, preconditionings with multi-grid solvers and all that kind of very difficult stuff. They can do this. But after 10, 20 years, you get tired, some of them. Mm-hmm. So we offer, our center, we offer an alternative career where they still are very good developers because they have good programming skills, they understand the science, but they're no longer asked to deliver research results as papers, but they become sort of like a half engineer, half, we call them experimental scientists. That's the system on the weekend, actually, not just our center. So after like 10, 20 years, people have the option, of course they get tenure, but they have the option of whether they pursue their lifetime career as a researcher, or of course they may move on to the university, become university professors or such, or some may go to the industry, but a lot of people like to be at Weekend because it's a very comfortable place to be. Mm-hmm. Mm-hmm. So, but they like to research, so what they may choose to do is to become sort of an engineer. Mm-hmm. Engineer still contribute to the science, right? Contribute to the domain because they update their software using the latest methods, but they're evaluated as making that type of contribution rather than publishing papers. Yeah.
That's fantastic.
So that's one model we thought we're finding it works very well for people, and they can still publish papers. Sometimes they do.
Sure.
Yeah, but it's not their mandate.
But it's an alternative path, so they have career growth.
Yeah.
Did that help at all? Excellent. Thank you. Other questions, thoughts? Yeah, I'll ask then the final question. We have 3 minutes left. It's been a wonderful conversation. Impact ultimately is what we all want in the academic world. We do research. We tackle some of the most complex, gnarly things. It's what kept me in the industry of high-performance computing my entire career. It's the possibilities that HPC and AI can unlock, right? So how do we make sure that our learnings really reach their intended targets? How do we make sure that they don't stay locked up inside sort of an academic environment, and that it actually really moves the needle on societal complex problems? You want to start, Francesca?
Yeah,
Thoughts?
it's very, very interesting question. I mean, I think that I would say the first question that we have to address is what is your stakeholder and what and who you're trying to impact and change your mind. So I mean, in my work, I've always been absolutely laser focused into changing environmental policy and climate policy. And so, that's where I want to go. And the reason why we breathe cleaner air, because there's been a change in policy, and the change in policy came because of the best data, right, and the best science. So knowing where you're going and the type of policy that you're going to change and what is the process, then what I do is I take the best possible data and the best possible methodology and science and rigor to inform that policy. And so I think that, when you were talking about impact, I think that in order to have an impact, the first order question is an impact on what and who and what type of lever you are trying to change.
Very fair.
And then working on that. And that's why I think data and data science and technology are now enable us to provide the type of evidence that we need to change a law in a much faster and, I would say, transparent way than before. I mean, even only 5 years ago, a lot of the decisions, whether there is a gun policy, environmental policy, social policy, healthcare policy, were made on opinion. And now we are at the time where anytime a policy is made on opinion, Fortunately, people can say, this is your opinion, but let's look at the data. And as soon as you say, look at the data, we immediately go back to our conversation.
Fantastic.
So where are you going to go? Where do you want to go? Who you want to impact? How you get there? And then you need to line up the best possible team and minds from science, technology, and policy to change that.
Love that. I know we're out of time. Final thoughts, Satoshi and Circe.
Oh yeah, with regards to that, of course, not every science has to, be impactful. We get a lot of, a lot of foundational,
Sure.
Startup sciences. But nonetheless, for example, Fugaku is a supercomputer. We took a poll, and about 70% of the Japanese population know what Fugaku is. And the reason is, one reason was we're not like number one in rankings, supercomputer rankings, all that. But the other reason was we made quite a bit of impact in terms of resolving some of the issues with respect to COVID transmissions. And that really really helped to curtail the transmission that allow people to kind of be locked down and all that. And we really made an effort, not just for our, to just promote ourselves, but of course, obviously, you want the results to proliferate to impact the society. But in the end, that really helped us to establish our basis, basically, to say that supercomputing is really important for the society. So it's really important endeavor to make sure that these types of facts are very well known.
Yes, I agree.
And in particular, like in modern days, like AI. Oops, just
think we're
in 1 second.
Yeah.
We're at time.
Okay.
Okay.
Yeah.
I'm sorry,
Yeah.
Circe. I just want to thank our panelists.